Have you ever gazed up at the night sky and felt that strange, almost electric connection between the stars above and the art inside you? That whisper of something bigger, something that ties the swirl of a galaxy to the stroke of a brush, the rhythm of a cosmos to the rhythm of a poem. It's no accident that some of humanity's most breathtaking art mirrors the universe's grandest designs. Think of Van Gogh's Starry Night, where the sky doesn't just hang, it pulses, alive with the same spiraling energy scientists later found in distant nebulae. Or the way ancient builders aligned temples with celestial events, weaving astronomy into architecture long before telescopes existed. There's a hidden dialogue between art and astrophysics, a conversation that's been unfolding for centuries, and today we're stepping right into the heart of it. This isn't just about pretty coincidences. It's about how the universe speaks in patterns that artists instinctively capture and scientists meticulously decode. Take the golden ratio, a mathematical secret hidden in seashells, galaxies, and Renaissance masterpieces, or the way light bends around cosmic giants just as it dances across an impressionist painting, revealing depth and mystery in both. These parallels aren't mere chance, they're clues to something deeper. Why does the human mind find beauty in the same shapes the universe repeats across infinite space? And what can a painter's intuition teach us about the laws of physics? That's the journey we're embarking on today, a voyage through 15 cosmic insights where art and astrophysics don't just overlap, they ignite each other. We'll explore how a sculptor's chisel mirrors the forces carving planets, how a composer's harmonies echo the vibrations of colliding stars, and why the greatest scientific minds often turn to art to explain the unexplainable. By the end, you'll see the night sky differently, not just as a scientist or an artist, but as someone who understands the silent, stunning language connecting both. So let's begin. The canvas is infinite and the stars are waiting. Long before telescopes pierced the heavens, human hands were tracing constellations onto cave walls, not just as maps of the stars, but as prayers etched in ochre and charcoal. That primal urge to capture the cosmos never faded. Fast forward to the Renaissance, when Leonardo da Vinci dissected light and shadow with the same precision astronomers charted planetary motion, both seeking the mathematical pulse beneath beauty. Even the swirling brushstrokes of Van Gogh's Starry Night, painted during a time when telescopes couldn't yet reveal spiral galaxies, somehow anticipated their structure, proof that art doesn't just reflect the universe, it anticipates it. Today, digital artists manipulate Hubble's nebula photos into ethereal landscapes, while composers like John Williams score symphonies that sonify celestial collisions. What's breathtaking is how often artists and scientists arrive at the same truths by different paths. Consider the mandala. Tibetan monks spend weeks crafting intricate sand circles only to sweep them away, mirroring the birth and death of stars in a ritual as old as the cosmos itself. Or take the haunting harmonies of Kepler's Harmonices Mundi, where the astronomer turned planetary orbits into musical notes, revealing a solar system that sings. This isn't mere inspiration, it's a kind of cosmic empathy. When a poet writes about the loneliness of a distant quasar or a sculptor shapes dark matter into tangible form, they're not just interpreting data. They're giving voice to the universe's silent questions, and every time science unveils a new wonder, a black hole's silhouette, the quantum dance of particles, artists absorb it like a second Big Bang, exploding into fresh creations. The cycle never ends. Discovery sparks art, art humanizes discovery, and together they remind us that the night sky isn't just something we observe. It's something we belong to. Vincent van Gogh's Starry Night isn't just a masterpiece of emotion, it's a cosmic blueprint in disguise. Look closely at those swirling skies, the way the paint seems to churn and ripple like a living thing. Decades after Van Gogh's death, physicists studying turbulence, the chaotic motion of fluids, found something astonishing. The same mathematical patterns that describe how air curls around a wing or how water spirals down a drain also appear in the painting's brushstrokes. But here's the twist: those patterns don't just exist here on Earth. They're woven into the fabric of the universe, visible in the turbulent clouds of distant nebulae and the magnetic storms raging across stars. How could an artist working in 19th century France with no formal training in science capture something so deeply rooted in the laws of physics? Some researchers suggest Van Gogh's unique perception, shaped by his mental state, allowed him to see and express natural turbulence in a way most of us filter out. His brushstrokes didn't just mimic the night sky, they echoed the universe's hidden rhythms, even more striking when scientists analyzed other works from his stable periods. The turbulence patterns faded. It was only during times of intense emotional upheaval that his art mirrored these cosmic flows. This isn't just a quirky coincidence. It's a testament to how art and science tap into the same underlying truths. The universe speaks in fractals, spirals, and waves, patterns our brains are wired to recognize, whether we're holding a paintbrush or a telescope. When astronomers study the whirlpool like arms of galaxies or the rippling shockwaves of supernova, they're seeing the same dance of chaos and order Van Gogh poured onto canvas. And that's the magic of this insight. Creativity doesn't just reflect reality. Sometimes it anticipates it. Long before supercomputers could simulate cosmic turbulence, an artist with a palette knife and a storm inside him painted the universe's heartbeat. So the next time you lose yourself in Starry Night, remember, you're not just looking at a painting, you're witnessing a conversation across time, where art and astrophysics meet in the whirl of something far greater than either could explain alone. The cosmos doesn't just inspire artists, it speaks through them. What if the same mathematical rule that shapes a sunflower's seeds also sculpted the Milky Way's spiral arms? Step into the world of the golden ratio, a number so precise, yet so universal. It bridges the gap between a painter's canvas and the architecture of galaxies. Take Leonardo da Vinci's Vitruvian Man, where the human body stretches within a perfect circle and square, every limb aligned to this divine proportion. The distance from head to navel versus navel to feet, the curl of an ear, even the spacing of fingers, all follow the golden ratio's magic number, 1.618. Now tilt your gaze upward. That same ratio appears in the logarithmic spiral of a hurricane, the curve of a nautilus shell, and astonishingly, in the whirlpool arms of galaxies like Messier 74. This isn't just aesthetics, it's efficiency written into the fabric of reality. In nature, the golden ratio allows for optimal packing, like sunflower seeds maximizing space as they spiral outward. In the cosmos, it governs how gravity sculpts galaxies, balancing rotation and density into those iconic spirals. But here's the wonder: Renaissance artists like Da Vinci and Botticelli didn't just stumble upon this pattern. They sought it deliberately, believing it mirrored the harmony of creation itself. Botticelli's The Birth of Venus positions the goddess precisely where the golden ratio's divine eye would fall, while the Parthenon's columns rise in golden steps, each measurement a silent ode to universal order. What does it mean that artists and astronomers keep finding the same hidden code? Perhaps the universe isn't just indifferent matter. Perhaps it composes itself like a symphony, repeating refrains across scales. When a painter like Georges Seurat placed dots of paint in golden ratios to create a Sunday afternoon on the island of La Grande Jatte, he was tapping into the same principle that arranges star clusters or the branching of trees. Even modern astrophysicists use the golden ratio to model galaxy formation, proving this ancient, artistic rule is hardwired into cosmic evolution. So the next time you see a spiral galaxy in a textbook or a Renaissance masterpiece in a museum, look closer. That curve, that balance, it's more than math or art. It's a whisper from the universe itself, reminding us that creativity and cosmos share the same blueprint. Whether through a painter's brush or a star's birth, the golden ratio whispers, beauty has a formula and the universe never forgets it. Light has always been the universe's greatest storyteller, not just illuminating the world but shaping it. To a physicist, light is a paradox, sometimes a wave, sometimes a particle, always defying simple explanation. To an artist, light is equally elusive, a tool to carve depth from flat canvas, to conjure emotion from pigment. Think of Caravaggio's dramatic chiaroscuro, where shafts of light slice through darkness like beams from a distant star, revealing faces with the same stark clarity as a telescope piercing cosmic dust. Or Monet's water lilies, where dappled sunlight shimmers like photons scattering through atmosphere, each brushstroke capturing light's fleeting dance. This duality runs deeper than technique. When photons stream from a star, they travel for millennia only to collide with a painter's eye, translating into color, shadow, and form. The same quantum quirks that baffle scientists how light can be both particle and wave also empower artists to bend perception. Take the pointillists like Seurat, who understood light's fragmented nature long before quantum theory. By placing tiny dots of pure color side by side, they mimicked how light itself blends in our vision, letting the eye weave particles into a luminous whole. Even the Hubble Space Telescope's images of nebulas, those radiant clouds where stars are born, echo the techniques of the old masters' layers of glowing gas painted by starlight, a celestial chiaroscuro written in hydrogen and helium. And what of darkness? Just as artists use shadows to give form to light, astronomers study the absence of light to map the universe's hidden structures. The blackest void in Rembrandt's The Night Watch isn't so different from the cosmic dark matter that bends starlight unseen. Both are negative spaces that define what we can see. When Turner painted sunsets so vivid they seemed to burn through the canvas, he was chasing the same interplay of scattering and absorption that turns a clear sky blue or a nebula crimson. Here's the wonder: whether trapped in oil paint or racing across space, light obeys the same rules. A prism splits sunlight into rainbows just as it splits starlight into spectra, revealing the elemental fingerprints of distant suns. The golden glow of a candle in Vermeer's Girl with a pearl earring and the golden ratio of a galaxy's spiral both bow to light's physics, one intimate, the other infinite. So next time you stand before a painting that seems to breathe with light, remember, you're not just seeing art, you're witnessing the universe's oldest language, spoken in photons and pigment, a dialogue between science and soul. A blank canvas holds as much power as the brushstrokes that fill it, a truth every artist knows. In the same way, the universe's greatest mysteries aren't just in the stars we see, but in the invisible spaces between them. Take the Japanese concept of Ma, where emptiness isn't just absence, it's an active force shaping everything from ink paintings to garden design. A single stroke of calligraphy gains meaning from the untouched paper around it, just as constellations emerge from the dark void of space. This interplay between presence and absence isn't just poetic, it's scientific. Astronomers mapping the cosmos face a puzzle. Galaxies spin too fast for the gravity of their visible stars to hold them together. Something unseen must be acting like cosmic glue, and they call it dark matter. It doesn't emit light, absorb it, or reflect it, yet its gravitational pull sculpts the universe like an unseen hand. Now step into a gallery where Anish Kapoor's void installations swallow light whole, their concave surfaces creating illusions of infinite depth. Stand before one, and you're not just looking at a sculpture, you're confronting the same unnerving pull a black hole exerts on spacetime. Kapoor's voids, polished to mirror like darkness, don't just occupy space, they redefine it, much like dark matter warps the paths of stars without ever revealing itself. Even Renaissance masters understood this power. In Michelangelo's Pietà, the hollows between Mary's robes and Christ's body aren't empty, they're charged with grief, carved as deliberately as the figures themselves. Here's the breathtaking parallel. Both artists and astrophysicists are detectives of the invisible. When Vera Rubin first uncovered evidence of dark matter in the 1970s, she was essentially measuring the universe's negative space, how unseen mass bent the paths of stars like an unseen sculptor. Modern telescopes map dark matter by tracing how its gravity distorts distant starlight, a technique eerily similar to how painters use shading to imply form. The Rubin Observatory, named in her honor, will soon scan the skies for these very distortions, proving once again that absence speaks volumes. Perhaps that's why black holes captivate both scientists and artists. They're cosmic embodiments of negative space, warping reality around their nothingness. Just as Kapoor's voids force us to question what's really there, dark matter challenges us to trust the evidence of things not seen. So next time you admire a painting where shadows carry as much weight as light, or a sculpture that makes emptiness tangible, remember, you're witnessing the same principle that holds galaxies together. The universe, it seems, is the greatest artist of all, mastering the balance between what we see and what we sense, between the stars and the silence that binds them. The universe hums with a secret symphony, one we're only just beginning to hear. NASA sonification projects transform the electromagnetic vibrations of distant stars, planets, and nebulas into haunting soundscapes, revealing that space isn't the silent void we once imagined. Take Saturn's rings, for example. The Cassini spacecraft captured their radio emissions, which scientists translated into eerie, metallic pulses like a celestial wind chime whispering across 1 billion miles. Or the Perseus galaxy cluster, where pressure waves ripple through superheated gas, producing a deep, resonant tone 57 octaves below middle C, a bass note no human ear could hear naturally. These aren't just scientific curiosities, they're the raw materials of a cosmic orchestra, waiting for artists to interpret them. Enter Gustav Holst's The Planets, composed decades before space probes could verify his instincts. When Holst scored Mars, the bringer of war, with pounding, dissonant rhythms, he unknowingly echoed the seismic tremors NASA would later detect on the actual planet. His Neptune, the mystic, floats on ethereal chords, mirroring the icy giant's slow, drifting auroras. Fast forward to today, where electronic musicians like Jean Mitchell-Jarre and Laurie Spiegel weave data from solar flares and pulsars into their compositions, turning astrophysics into avant-garde sound art. The crossovers defy coincidence. Jupiter's great red spot vibrates at frequencies similar to Tibetan singing bowls, while the harmonic resonance between orbiting moons matches the mathematical ratios of a perfect musical fifth. But here's the revelation: these parallels aren't poetic license, they're physics in action. Orbital resonance, the phenomenon that keeps planets and moons locked in gravitational sync, operates on the same principles as harmonic intervals in music. When Jupiter's moons Io, Europa, and Ganymede align in their orbits, Their gravitational pull creates rhythmic patterns identical to the vibrations of a plucked string. Composers from Bach to Brian Eno have exploited these same ratios, proving that harmony isn't just a human invention. It's woven into the fabric of space-time. Perhaps that's why the ancient Greeks imagined the music of the spheres, a celestial concert where planets sang as they moved. Modern science has replaced myth with math, but the awe remains. When you hear a choir's voices blend into a single chord, or a violin's note resonate through a concert hall, you're experiencing the same laws that govern galaxies. The universe doesn't just have rhythm, it is rhythm from the quantum vibrations of atoms to the grand, slow dance of colliding galaxies. So the next time music gives you chills, remember, you're not just feeling art. You're feeling the pulse of the cosmos itself, translated into something your soul can understand. Fractals are the universe's signature, a pattern so versatile, it scales from the veins of a leaf to the sprawling filaments of the cosmic web. Picture Hokusai's The Great Wave, where every curl of foam echoes the larger swell, a miniature of the whole. The same self-similarity appears in Romanesco Broccoli's spiraling florets, river deltas branching like nerves, and even the jagged edges of coastlines viewed from space. These aren't just artistic choices or random shapes, they're mathematical inevitabilities, the result of simple rules repeating infinitely. And when astronomers map the large-scale structure of the universe, they find something eerily familiar: galaxy clusters strung along filaments, weaving a web that mirrors the fractal branching of neurons in the human brain. This recursive beauty isn't coincidental, it's efficiency coded into existence. Nature favors fractals because they maximize surface area, optimize energy flow, and adapt flawlessly to chaos. A tree's fractal branches catch sunlight efficiently, just as the cosmic web's filaments channel galaxies along gravitational highways. Digital artists harness these principles too, using algorithms to generate landscapes where every mountain range contains tiny, perfect replicas of itself. Compare that to the Mandelbrot set, the most famous fractal of all. Zoom in endlessly, and you'll find the same intricate shapes recurring, a universe in miniature. Astronomers see similar scaling in the distribution of matter, whether you're observing galaxies millions of light-years apart or dust grains in a protoplanetary disk. The clustering patterns stay eerily consistent. What does this mean for the bridge between art and astrophysics? Fractals suggest a universe that speaks in echoes. When Jackson Pollock dripped paint onto canvases, his chaotic splatters hid a secret. Scientists analyzing them found fractal dimensions matching natural turbulence. Tribal artists painting intricate dot patterns or Islamic artisans crafting tessellating mosaics were tapping into the same geometric truths that govern quasar emissions or the fractal-like froth of the early universe. Even our own circulatory systems, with their fractal branching, mirror the cosmic web's design. Perhaps that's the deepest insight of all. The universe doesn't just contain art, it operates artistically. The same forces that sculpt clouds and shorelines also shape superclusters and nebulae. So the next time you lose yourself in the hypnotic swirl of a fractal artwork or a Hubble image of interstellar dust, remember, you're not just seeing a pattern. You're witnessing the universe's favorite blueprint, a rhythm so fundamental, it repeats from the infinitesimal to the infinite. And in that repetition, we find something astonishing, a cosmos that feels less like a machine and more like a masterpiece, endlessly iterating on its own perfect theme. Time doesn't flow like a river, it bends, stretches, and sometimes melts like the clocks in Salvador, dollies the persistence of memory. Those drooping timepieces aren't just surreal fantasy, they're an uncanny visual metaphor for Einstein's theory of relativity, where time warps under gravity's pull. Imagine standing near a black hole where seconds crawl like hours compared to Earth. That's time dilation in action, a phenomenon as bizarre as any dream Dolly ever painted. Yet both Einstein and the Surrealists arrived at the same startling truth. Time isn't rigid. It's elastic, subjective, and deeply strange. Consider how relativity upended our cosmic clock. The faster you move, the slower time passes for you relative to someone standing still. A fact astronauts experience when returning to Earth younger than if they'd stayed home. Now look at Dolly's limb clocks draped over branches like wet cloth. They capture time's malleability with eerie precision, as if the artist intuited physics decades before satellites could measure it. Even the ants swarming one clock echo quantum decay, where particles break down unpredictably over time. Sci-fi creators latched onto this idea too. Films like Interstellar show planets where hours stretch into years elsewhere, while Doctor Who's TARDIS bends space-time like a surrealist's brushstroke. But here's the twist: science and art don't just mirror each other, they fuel each other's breakthroughs. When Einstein published his theories, artists like Dolly and Marcel Duchamp seized on them, using relativity to shatter traditional perspectives. Duchamp's nude descending a staircase superimposes motion in a single frame, much like space-time diagrams tracing an object's path through warped dimensions. Meanwhile, physicists wrestling with time's paradoxes often turn to art for clarity. Nobel laureate Roger Penrose collaborated with Dolly on works like Corpus Hypercubus, merging tesseracts and crucifixion to visualize higher dimensions. This interplay reveals something profound. The most revolutionary science feels like art. Black holes distorting light into rings, wormholes folding space like origami. These concepts demand creativity as much as calculation. Perhaps that's why the iconic imagery of relativity, those rubbery grids representing warped space-time, looks so much like abstract expressionism. Both are attempts to translate the untranslatable, to make the invisible felt. So the next time you see a melted clock or a sci-fi portal twisting reality, remember, you're not just looking at fantasy, you're witnessing a collaboration across centuries, where physicists and painters together unmask time's true face, not as a ticking hand, but as a shape-shifter, dancing to the universe's hidden rhythms. Hubble's portraits of nebulae don't just document the cosmos, they reveal it as the most breathtaking art gallery imaginable. Those billowing clouds of hydrogen and helium, painted by the light of newborn stars, could pass for delicate watercolor washes if hung beside a Georgia O'Keeffe canvas. Take the pillars of creation in the Eagle Nebula. Their wispy tendrils of gas, backlit by stellar radiation, blur into gradients as soft as ink bleeding into wet paper. Or the Veil Nebula's filaments stretching like brushstrokes across space, their edges diffusing into the void just as pigment fades at the edge of a wash. This isn't mere resemblance, it's shared physics. Both nebulae and watercolors rely on diffusion, the way particles spread and mingle under forces like gravity or capillary action. O'Keeffe's luminous florals, with their petal edges dissolving into abstraction, capture the same ethereal quality as Orion Nebula's glow. She once said she wanted to paint what I see and what the flower is to me, distilling essence over literal form, a process not unlike how telescopes translate raw data into images that resonate emotionally. Even the tools align. Hubble's filters isolate specific wavelengths of light, much as a watercolorist layers translucent glazes to build depth. The result: cosmic landscapes that feel paradoxically intimate, as if the universe crafted them to be felt, not just studied. But here's the revelation: these techniques aren't just aesthetic choices, they're nature's defaults. When a star explodes, its shockwaves paint the surrounding gas with the same chaotic elegance as a painter flicking droplets across paper. The Rosette Nebula's rosette-like swirls emerge from stellar winds sculpting dust, while J. M.W. Turner's stormy seascapes harnessed similar fluid dynamics in pigment. Even the happy accidents watercolorists cherish on planned blooms and backgrounds mirror the unpredictable interactions of cosmic plasmas. This duality hints at something profound. Whether through a quill pen or a supernova, creation follows universal rules of flow and interaction. The next time you see a nebula's delicate hues or a watercolor's radiant bleed, remember, you're witnessing the same dance of energy and matter, one scaled to a human hand, the other to the infinite. The cosmos doesn't just inspire art, it collaborates. Symmetry is the silent language of the universe, whispered in the curve of a seashell and shouted from the spiraling arms of galaxies. It's the thread that stitches together the sacred and the scientific, from the atomic dance of quantum particles to the hypnotic precision of a mandala. Consider the exquisite tessellations of Islamic geometric art, those interlocking stars and polygons that adorn mosques and manuscripts. At first glance, they're purely decorative, but look deeper. These patterns aren't just beautiful, they're mathematical prayers, reflecting the infinite and unchanging nature of the divine through perfect repetition. Now zoom into the scale of a single cell. The DNA double helix, with its mirrored strands twisting in flawless harmony, obeys the same rules of symmetry. Both the artist's compass and the chemist's model reveal a truth. Balance isn't just pleasing to the eye, it's woven into the fabric of existence. This obsession with symmetry isn't arbitrary. In physics, it's a guiding principle so fundamental that Nobel laureates like Young and Mills built entire theories around it. Their work shows how the universe's forces, electromagnetism, gravity, even the strong nuclear force, emerge from symmetrical relationships between particles. Break that symmetry and reality as we know it unravels. The Higgs boson, discovered in 2012, exists precisely because symmetry can break, giving particles mass. Meanwhile, Tibetan monks crafting sand mandalas understand this intuitively. Their intricate circles, radiating from a central point, aren't just spiritual symbols, they're maps of cosmic order, mirroring the fractal symmetry of snowflakes and the orbital paths of planets. What's mesmerizing is how these parallels transcend time and culture. The flower of life, an ancient symbol found in Egyptian temples and Chinese artifacts, layers interlocking circles into a blueprint of creation, a pattern echoed in the way soap bubbles cluster or atoms arrange in crystals. Even the stained glass rose windows of Gothic cathedrals, with their kaleidoscopic symmetry, mimic the structure of quasicrystals, materials whose atoms align in near-perfect patterns once thought impossible. Science and sacred art, it seems, are two dialects of the same language. Perhaps that's why symmetry feels transcendent, whether in a physicist's equation or a stained glass saint's halo. It hints at a universe where chaos is the exception, not the rule. When CERN particle colliders reveal new symmetries in subatomic debris, or a child spins a kaleidoscope to watch shapes multiply into infinity, they're touching the same truth. Repetition isn't monotony. It's the universe's way of saying this matters. From the hexagonal eyes of a honeycomb to the spiraling jets of a newborn star, symmetry is the signature of a cosmos that builds by folding, echoing, and returning, always returning to balance. The Hubble Deep Field isn't just a photograph, it's a love letter to the power of patience and perspective. Imagine pointing a telescope at what seems like an empty patch of sky, a void no larger than a grain of sand held at arm's length. Then, over hundreds of hours, light trickles in not from one or two stars, but from thousands of galaxies, each a swirl of billions of suns. The result? A tapestry so dense with detail, it mirrors Georges Seurat's A Sunday Afternoon on the island of La Grande Jatte, where countless tiny dots of paint coalesce into a shimmering whole. Both the astronomer and the artist understood something profound. Isolation reveals nothing, but accumulation reveals everything. Zoom into the Hubble deep fields, empty, void, and galaxies explode into view like brushstrokes resolving under a magnifying glass. Some are spiral arms caught mid-twirl, others are smudges of light from epochs when the universe was barely a toddler. Each pixel holds a story, just as each dot in Seurat's park scene, a parasol, a bonnet, a ripple on the Seine, builds toward a moment frozen in time. The technique is identical, discrete fragments creating depth through density. For Seurat, this was pointillism, the science of optics applied to art. For Hubble, it's deep field imaging, the art of revelation applied to science. Both transform noise into narrative, proving that what looks like chaos is often just a matter of scale. Here's the magic: neither the painting nor the photo could exist without embracing the unseen. Seurat's dots only make sense when you step back, just as Hubble's galaxies only whisper their secrets after days of exposure. The longer you look, the more they give tiny red dwarfs in the painting's shadows, dwarf galaxies in the photo's corners. And just as Seurat mixed colors not on his palette but in the viewer's eye, Hubble's team assigns false colors to wavelengths invisible to us, letting our brains synthesize the invisible into something breathtaking. This isn't just technical mastery, it's philosophy in action. The deep field and La Grande Jatte both challenge us to reconsider what nothing really means. That blank sky holds more galaxies than there are grains of sand on Earth, just as Seurat's simple park scene teems with social hierarchies and hidden narratives. Both remind us that the universe rewards those who linger, who collect the faintest whispers of light or pigment until the bigger picture emerges. So the next time you feel small under a starry sky, remember, you're not just looking up. You're standing in the Hubble deep field of your own life, surrounded by dots of experience that only make sense when you step back. The cosmos and the canvas agree the details aren't just details. They're the whole story. Cosmic rays streak through the void like invisible brushstrokes, painting their wild trajectories across the night sky. And when they collide with Earth's atmosphere, they burst into showers of particles that leave trails as frenetic as a Jackson Pollock canvas. Scientists capture these paths in cloud chambers, where the ionized tracks twist and fork like liquid splatters frozen in mid-air. The resemblance isn't just visual, it's philosophical. Pollock's drip paintings weren't random, they were choreographed chaos, capturing the raw energy of motion the way a physicist traces subatomic collisions. His loops and spatters mirrored the same unpredictable forces that send cosmic rays careering across galaxies, both artists and astronomers documenting the universe's untamed heartbeat. Wassily Kandinsky took this idea further, abandoning recognizable forms altogether to paint the unseen, the vibrations of color, the resonance of shapes, what he called the inner necessity of art. His swirling compositions, like Composition 8, pulsed with an energy that echoed the very particles physicists were just beginning to understand: electrons spinning in orbitals, gamma rays flashing through space. Kandinsky believed art should express the spiritual forces beneath reality, a conviction that paralleled Einstein's quest to unveil the hidden fabric of spacetime. While scientists built bubble chambers to visualize cosmic rays, Kandinsky wielded oils and gouache to manifest the invisible, both translating cosmic whispers into something the human mind could grasp. The magic lies in the method. Pollock's technique, dripping paint from above, letting gravity and momentum guide each drop, uncannily resembles how high-energy particles interact with magnetic fields, their paths bending in arcs too vast to see. Even the tools align. Physicists use photomultipliers to catch faint streaks of light from particle decays, while Pollak's layered skeins of enamel catch light like dimensional artifacts, each strand a record of kinetic energy preserved. And just as astronomers study cosmic rays to decode the universe's most violent events, supernova, quasars, colliding neutron stars, art historians dissect Pollak's layers to uncover the sequence of his movements, both disciplines reconstructing history from fragmented evidence. This convergence isn't coincidence, it's a testament to how creativity and curiosity collide. When a cosmic ray detector in Antarctica picks up a muon from some distant cataclysm, and a painter in New York flings pigment onto a canvas, they're participating in the same ancient dialogue, one about chaos, energy, and the urge to leave a mark. The universe doesn't distinguish between art and science. It simply is in all its messy, radiant splendor. And every time we map a particle's path or lose ourselves in a Kandinsky swirl, we're reminded the most profound truths often lie not in the tidy equations, but in the wild, uncharted spaces between them. Einstein predicted it, and Hubble proved it, the universe's most dazzling magic trick, where galaxies bend light like glass, distorting a face in a carnival mirror. Gravitational lensing, the phenomenon where massive objects warp spacetime so profoundly that they twist the paths of passing photons, doesn't just magnify distant stars, it fractures them into arcs and rings, a cosmic kaleidoscope. Now step into Picasso's studio circa 1907, where Les Demoiselles d'Avignon shatters the human form into jagged planes, forcing the viewer to see a face simultaneously from the front, side, and three-quarters view. The connection isn't metaphorical, it's foundational. Both Einstein and the cubists were dismantling the illusion of a single, fixed perspective, revealing that reality, whether seen through a telescope or a paintbrush, is infinitely more fluid than we imagine. Consider the Hubble Space Telescope's image of galaxy cluster Able 68, where lensing stretches a spiral galaxy into a glowing, elongated smile. The cluster's gravity doesn't just bend the galaxy's light, it replicates it, creating mirror images like a celestial hall of mirrors. This eerie duplication mirrors Georges Braque's violin and candlestick, where objects fragment and multiply across the canvas, their edges bleeding into one another. Both the physicist and the painter are asking, where does one thing end and another begin? When gravity distorts a quasar's light into a cross-shaped mirage, a phenomenon called an Einstein cross, it's not so different from Juan Gris's cubist still lifes, where a newspaper, a glass, and a tabletop intersect until they're indistinguishable. The universe, it seems, has always been cubist. We just needed art and science to catch up. But here's the twist. These warped perspectives aren't just curiosities. They're tools for discovery. Astronomers use gravitational lenses as natural telescopes, peering around cosmic corners to spot galaxies too faint to see otherwise. Similarly, cubism's fractured viewpoints unveiled hidden dimensions of emotion and motion, like showing a guitarist's fingers in multiple positions at once to capture the act of playing. Even the technique aligns. Just as Picasso layered translucent planes to suggest depth, astronomers stack lensed images to reconstruct the true shape of distant objects. The Hubble Deep Field's most distant galaxies, many were found thanks to lensing's magnifying effect, their light bent and amplified by foreground clusters, a cosmic collaboration between mass and light that feels almost artistic. This interplay reaches its zenith with black holes, where space-time curves so violently that light loops back on itself like a Möbius strip. The Event Horizon Telescope's image of M87's black hole, with its fiery ring of lensed light, could hang beside Duchamp's nude descending a staircase. Both are portraits of motion and distortion, one painted by gravity, the other by a radical reimagining of time. The lesson is clear: reality isn't a fixed stage. It's a funhouse, a hall of mirrors, a canvas where every observation, whether scientific or artistic, changes the very thing being observed. So the next time you see a cubist painting or a lensed galaxy, remember, you're not just seeing distortion, you're seeing deeper. A black hole's event horizon isn't just a boundary, it's the ultimate canvas of paradox, a darkness so profound it mirrors Kazimir Malevich's Black Square, that iconic modernist painting which reduced art to its most elemental form. Malevich called his work the face of the new art, a void charged with infinite potential. Strip away the frame, and you're left with something eerily similar to a black hole's silhouette, an abyss that isn't empty, but full of warped space-time, of questions, of the universe's raw creative force. Both the artist and the astrophysicist confront the same challenge: how to represent the unimaginable. For Malevich, it meant rejecting figurative art to evoke pure sensation. For scientists imaging the black hole in galaxy M87, it meant translating radio waves into a fiery ring, a visual metaphor for light itself being swallowed. This collision of art and science ignites most vividly in sci-fi. Films like Interstellar depict black holes as luminous maelstroms, their accretion disks twisting like Van Gogh's Starry Night on a cosmic scale. Video games like No Man's Sky render them as shimmering gateways, echoing ancient myths of portals to other worlds. Even the Event Horizon Telescope's landmark photo, with its hazy gold halo, feels less like a snapshot and more like a Rothko, a study in thresholds where color and void meet. These artistic choices aren't just dramatizations, they're necessary translations. Black holes defy direct observation, so we cloak them in symbolism, just as Malevich used abstraction to convey the ineffable. But here's the twist: the most accurate depictions of black holes often look the most surreal. Einstein's equations predict that a black hole's gravity would lens background light into a perfect ring, wrapping the cosmos around itself like a dolly clock melting into a circle. Artists like Lynette Cook take this further, painting black holes as kaleidoscopic funhouses where galaxies stretch into spaghetti-thin strands. It's no coincidence that the term event horizon sounds like something from a Beckett play, a boundary where normal rules collapse and time stretches into absurdity. What unites these visions is the human urge to frame the infinite. Malevich's Black Square wasn't nihilism. It was a reset button, inviting viewers to project their own meaning onto the void. Similarly, every rendering of a black hole, whether in a scientific paper or a Marvel movie, is a Rorschach test for our cosmic anxieties and hopes. Do we see annihilation? Transformation, a door to someplace new. The black hole, like the black square, refuses to answer. It simply is a monument to the limits of perception and the audacity of those who try to depict it anyway. Perhaps that's why both captivate us. They're mirrors held up to the unknown, reflecting back not just what we see, but how we see. When Malevich exhibited Black Square in 1915, he hung it high in a corner like a Russian Orthodox icon. Today, the Event Horizon Telescope's image of M87's black hole occupies a similar altar, a digital relic for the age of astrophysics. One was painted with a brush, the other with radio waves, but both whisper the same truth: some mysteries can't be solved. They can only be felt in the quiet awe between the equations and the abyss. The discovery of an exoplanet begins with numbers, a flicker in starlight, a wobble in radial velocity data, but it doesn't stay that way for long. Within hours of astronomers announcing a new world, concept artists are already dreaming its skies into being, translating cold metrics into jungles of bioluminescent trees or deserts of crystalline sand. Take Kepler 186f, a rocky planet in its star's habitable zone. Scientists know its mass, its orbit, the likely composition of its atmosphere. But what does sunset look like there? That's where artists like Lynette Cook step in, painting double suns casting violet shadows across alien mountain ranges, or twin moons hanging over methane seas. These visions aren't just pretty speculation, they're rigorous thought experiments. When Cook imagines a planet with a thick carbon dioxide atmosphere bending light into perpetual golden hour, she's building on real atmospheric physics, the same science that guides NASA climate models. This synergy between discovery and imagination reaches its peak in films like Avatar, where Pandora's floating mountains and neon flora aren't pure fantasy. Director James Cameron consulted with exobotanists and astrophysicists to ensure Pandora's ecology made sense under its fictional star. The result? A world where plants communicate through underground fungal networks, a real phenomenon called mycorrhizal networks, scaled up with artistic license. Even the film's iconic bioluminescence everywhere aesthetic has roots in Earth's deep sea vents, where life thrives without sunlight. By grafting scientific plausibility onto wild creativity, Avatar did more than entertain. It expanded our sense of what's possible. Suddenly, a planet where flora glows in response to seismic activity or fauna, uses magnetic fields to navigate doesn't seem so far-fetched. But the most fascinating collisions happen when artists and scientists challenge each other. Astronomers identifying Hycean planets' water worlds with hydrogen-rich atmospheres inspired artists to depict oceans so deep their pressures create exotic ice forms hotter than lava. Conversely, a concept painting of a tidally locked planet with a permanent hurricane over its sunlit side led climatologists to run new simulations on atmospheric dynamics. The feedback loop is relentless. Every discovery sparks new art, every artwork prompts new questions. When the TRAPPIST-1 system revealed 7 Earth-sized planets orbiting a red dwarf, artists flooded the internet with renditions, some showing terraformed oases, others depicting barren rocks bathed in eternal crimson twilight. This interplay forces us to confront how Earth-centric our definitions of life remain. A biologist might assume alien plants would photosynthesize, but under a red star, life might evolve to harness infrared radiation instead, turning entire forest shades of black to absorb every photon. A planet with extreme axial tilt could have seasons lasting centuries, inspiring migrations more mythic than anything on Earth. Even time itself bends differently. On Proxima Centauri b, a year lasts 11 Earth days, raising the eerie possibility of civilizations where generations bloom and fade in what we'd call a single summer. Perhaps that's why exoplanet art captivates us. It's not just about alien landscapes, but about alien logic. When you see a painting of a silicon-based life form sculpting castles from molten glass under a blue-white star, you're glimpsing a universe that refuses to play by our rules. And that's the true gift of this collaboration. Every brushstroke and equation whispers the same thrilling truth. We're not just finding new worlds, we're learning how to see them. What if every choice you've ever made spawned a new universe? One where you took that job overseas, one where dinosaurs never went extinct, one where the laws of physics themselves unraveled into something unrecognizable. This isn't just the plot of a sci-fi novel. It's a real possibility in string theory, where the multiverse isn't a metaphor but a mathematical inevitability, a cosmic kaleidoscope of infinite realities, each with its own unique rules. And here's the twist. Artists and writers have been mapping these alternate dimensions for centuries, long before physicists put pen to equation. Jorge Luis Borges' The Garden of Forking Paths envisioned time as a labyrinth where every decision branches into new timelines, a concept eerily similar to the many worlds interpretation of quantum mechanics. Meanwhile, M.C. Escher's relativity gave us staircases that looped into paradox, where up and down lost all meaning, a visual echo of Calabi-Yau manifolds, those twisted six-dimensional shapes string theorists say could hide extra dimensions right under our noses. The parallels between these surreal narratives and cutting-edge physics aren't accidental. Both grapple with the same existential vertigo, that reality might be far stranger than our senses can comprehend. Take Schrödinger's famous cat, simultaneously alive and dead until observed. Borges' short story, The Library of Babel, imagines a universe as an infinite archive containing every possible book, most gibberish, but somewhere the perfect text explaining everything. It's the literary equivalent of the multiverse's anything that can happen, does happen mantra. Even Salvador Dali's The Disintegration of the Persistence of Memory, with its floating bricks and fragmented clocks, mirrors string theory's idea that space-time might dissolve into vibrating strings at the tiniest scales. But why does this matter? Because the multiverse isn't just a scientific hypothesis, it's a cultural mirror. When Marvel's Loki series explores the chaos of branching timelines, or Everything Everywhere All at Once turns quantum jumps into a madcap family drama, they're doing the same work as theoretical physicists, helping us feel what equations can't convey. String theory's equations might describe 11 dimensions, but it took a graphic novel like Flatland to make higher dimensions relatable, showing how a three-dimensional being would seem godlike to two-dimensional creatures. Art doesn't just illustrate science, it makes it human. This final insight isn't about answers, it's about liberation. The moment we accept that our universe might be one page in an infinite book, or one frame in an endless film strip, something shifts. Suddenly, Van Gogh's Starry Night isn't just a painting, it's a portal to a universe where turbulence rules. Borges' Labyrinth isn't just fiction, it's a roadmap to the quantum foam. And Escher's staircases, they're not impossible, just waiting for us to discover the right dimension to climb them. The greatest gift of the multiverse idea isn't proof. It's permission to wander, and to create as if every brushstroke or equation might birth a cosmos of its own. Galileo's sketches of the moon's pockmarked surface weren't just scientific records, they were revelations disguised as art. Armed with nothing more than a rudimentary telescope and an engraver's precision, he transformed the moon from a celestial myth into a tangible world, its mountains and valleys rendered with the delicate shading of a Renaissance master. Those drawings did more than document, they persuaded, using beauty to bypass skepticism. When critics insisted the moon was a perfect sphere, Galileo's intimate, almost tactile renderings of its rugged terrain made the truth undeniable. Science needed his artist's hand as much as his mathematician's mind, because discovery isn't just about data, it's about seeing and helping others see too. A century later, Étienne Léopold Trouvelot took this fusion further. By day, he was a meticulous astronomer charting sunspots and Jupiter's storms. By night, he became a painter, translating his observations into pastels so vivid they seemed to glow. His Aurora Borealis wasn't just a diagram of magnetic storms, it was a swirling dreamscape of emerald and crimson, capturing the phenomenon's eerie dance in a way raw numbers never could. Trouvelot understood something profound. Accuracy and artistry aren't rivals, they're partners. His pastel of Saturn's rings, with their ethereal transparency and delicate shadows, revealed details photographic plates of his era couldn't prove that the human eye, guided by an artist's intuition, could tease out nuances machines missed. This legacy lives on in modern astrophotographers like David Malin, who pioneered techniques to coax color from the monochrome void of space. His images of the Horsehead Nebula, rich with sapphire and garnet hues, aren't mere enhancements, they're translations, revealing chemical compositions through carefully mapped palettes. Just as Galileo's sketches made the moon feel real, Malin's photos remind us that the cosmos isn't cold or distant. It's alive with light we're only beginning to decode. The lesson here transcends astronomy. When Caroline Herschel catalogued comets with the same patience she'd once applied to embroidery, or when Maria Mitchell swept the skies with a poet's sensitivity to pattern, they proved that breakthroughs happen where rigor meets wonder. The best scientists don't just calculate, they curate, selecting which details matter, and framing them in ways that spark collective awe. So the next time you gaze at a Hubble image or a vintage star map, remember, you're not just looking at science. You're witnessing the quiet rebellion of those who dared to see the universe not only as it is, but as it feels. Astrophotography isn't just pointing a camera at the sky. It's a high-wire act between precision and poetry, where the cold math of exposure times collides with the warmth of human vision. Take the iconic pillars of creation image from the James Webb Space Telescope. Those towering columns of gas and dust, glowing in hues of gold and cobalt, aren't exactly what your eyes would see if you floated nearby. Webb captures infrared light, wavelengths invisible to us, so scientists assign colors to represent different chemical elements: oxygen as blue, hydrogen as green, sulfur as red. This isn't deception, it's translation. Just as Van Gogh exaggerated the swirls of the night sky to convey its emotional weight, astronomers amplify certain features to reveal the universe's hidden stories. The result, a portrait where science and artistry share the same frame. But the artistry begins long before the editing software. Composition matters as much in astrophotography as it did for Ansel Adams framing Yosemite's cliffs. A skilled photographer might position the Andromeda galaxy off-center, letting its spiral arms lead the viewer's eye across a star-strewn canvas. Others chase the perfect foreground, a gnarled tree or a lone desert rock, to anchor cosmic vastness in something tactile. The best shots don't just document, they invite, using the same tricks as Renaissance painters: depth, contrast, balance. When photographer Babak Tafreshi captures the Milky Way arching over an ancient temple, he's not just stacking exposures. He's weaving time and space into a single moment, reminding us that the stars above and the stones below share the same atomic ancestry. Yet even the most breathtaking images demand a brutal intimacy with failure. Unlike landscape photographers, astrophotographers can't control their subject. A passing satellite, a gust of wind, or a sudden bank of clouds can ruin hours of work. It's why some of the most patient artists thrive here, people like amateur astronomer Judy Schmidt, who spent months reprocessing raw Hubble data to tease out the delicate filaments of a dying star in unprecedented detail. Her work isn't just pretty pictures, it's archaeology, dusting off light that's traveled millennia to reach us. What's revolutionary is how these images reshape our relationship with the cosmos. When Webb's team releases a false color rendering of a distant exoplanet's atmosphere, they're not just sharing data, they're offering a feeling, the awe of methane winds or the eerie glow of a hydrocarbon haze. It's no coincidence that the most viral space images resemble abstract expressionist paintings. The Carina Nebula's cliffs of gas, rendered in turquoise and ochre, could hang beside a Helen Frankenthaler pour. The Tarantula Nebula's intricate tendrils echo the organic forms of Yayoi Kusama's infinity nets. The universe, it seems, has always been an artist, so the next time you lose yourself in a deep field image, remember, you're not just seeing a snapshot. You're witnessing a collaboration across disciplines where engineers, astronomers, and yes, even poets with cameras conspire to turn photons into portals. The telescope collects the light, but the human hand and heart decides what it means. Dark matter doesn't glow. Gravitational waves don't ripple visibly through space. Yet, thanks to the alchemy of data visualization, we can see them not as raw numbers, but as swirling galaxies of color and form that would make Kandinsky gasp. Scientists wrestling with the universe's most elusive phenomena face a paradox: how to make the invisible palpable. Their solution: turn datasets into art. When LIGO detected the first gravitational waves in 2015, the signal was a faint wobble in a graph, but the team's visualization transformed it into a spreading ripple of gold and blue, echoing across a black expanse like a stone dropped in cosmic pond. Suddenly, Einstein's century-old prediction wasn't just a theory. It was a texture, something you could almost reach out and touch. This marriage of rigor and creativity reaches its zenith in projects like the Dark Matter Visualization Project, where astrophysicists teamed with digital artists to sculpt vast webs of unseen matter into three-dimensional landscapes. Using supercomputer simulations, they mapped dark matter's gravitational scaffolding as luminous tendrils connecting galaxies, a structure eerily reminiscent of neural networks in the human brain. The resemblance isn't just striking, it's strategic. By borrowing techniques from abstract expressionism, layers of translucent color, dynamic brushstroke-like filaments, they gave form to the formless, helping even non-scientists grasp how dark matter binds the universe together. But here's where it gets fascinating. These visualizations aren't just explanatory tools. They've begun influencing art itself. Digital creators like Rafik Anadol feed cosmic datasets into AI algorithms, generating immersive installations where particles of dark matter dance across gallery walls like living paint. NASA Chandra X-ray Observatory collaborates with musicians to sonify nebula emissions, turning star death into symphonies. The line between lab and studio blurs further with tools like Unreal Engine, originally designed for video games, now used to render real-time simulations of black hole mergers. When you watch two supermassive black holes spiral toward collision in a VR headset, their accretion disks flaring like Van Gogh suns, you're not just learning astrophysics. You're experiencing it. Critics might dismiss these creations as mere eye candy, but they miss the point. Scientific visualization follows the same rules as great art. Composition matters, contrast reveals depth, and color evokes emotion. The Hubble palette, a technique assigning specific hues to elements like oxygen, hydrogen, and sulfur, doesn't just make nebulas prettier, it highlights their chemical drama. When the Event Horizon Telescope rendered M87's black hole in fiery oranges, they weren't being decorative. They were tapping into primal associations: heat, danger, energy, to telegraph the object's unimaginable power. Perhaps that's why these images resonate so deeply. They satisfy a craving older than science itself, to witness the sublime. Before telescopes, humans painted constellations as gods and beasts. Now we map dark matter as glowing fractals, but the impulse remains unchanged. Whether through pigment or pixels, we're still telling the same story, one where the universe isn't just equations, but something that moves us. So the next time you see a visualization of the cosmic microwave background or a neutrino's path through a detector, don't just analyze it, feel it. After all, every dataset is a canvas waiting for the right hand to bring it to life. When NASA invited Laurie Anderson to become their first artist in residence, they weren't just handing her a lab coat, they were opening a portal between worlds. Anderson, a pioneer of avant-garde music and performance art, spent months embedded with engineers and astrophysicists, translating the rhythms of satellite data into her haunting songs for space. The result, a symphony where radio waves from Jupiter's magnetosphere became percussion, and the vibrations of solar winds morphed into eerie, wordless vocals. This wasn't just art about space, it was art made from space, a literal fusion of cosmic signals and human creativity. NASA artist collaborations go far beyond music. Take Rafik Anadol's machine hallucinations, where he fed decades of asteroid trajectory data into AI algorithms, transforming cold coordinates into swirling, dreamlike projections. Watching his installations feels like stepping inside a meteor shower, where each glowing streak represents a real celestial body's path, a reminder that even the driest datasets contain hidden poetry. Meanwhile, digital artist Sarah Mayo has collaborated with NASA, a jet propulsion laboratory, to create Cloud of Petals, using satellite imagery of Earth's surface to generate infinite, algorithmically unique petals. The project blurred the line between map and metaphor, asking whether a landscape seen from orbit is still a place or something closer to a memory. These partnerships thrive on mutual curiosity. When painter Lynette Cook toured the Keck Observatory, astronomers showed her raw spectral data from exoplanet atmospheres, charts of squiggly lines indicating methane or water vapor. Cook's response: she painted those squiggles as auroras dancing over alien horizons, turning graphs into gas giants you could almost walk on. Conversely, when composer Terry Riley worked with NASA Ames Research Center, his experimental music inspired engineers to rethink how they visualized cosmic radiation patterns. The feedback loop is relentless. Art humanizes data, and data stretches art's boundaries. Perhaps the most unexpected collaboration came from sculptor Maya Lin, best known for the Vietnam Veterans Memorial. For her Earth Observatory project, she partnered with glaciologists to map vanishing ice sheets, carving their contours into massive marble discs. The artwork doubled as a climate time capsule, each groove marking a glacier's retreat, each curve echoing satellite altimetry. Lin's work didn't just illustrate science, it embodied it, making planetary changes visceral in a way graphs never could. These projects prove something profound: creativity and calculation aren't opposites. They're twin languages for deciphering the universe. When a choreographer interprets zero-gravity motion through dance, or a poet writes verses from the perspective of a Mars rover, they're not just borrowing from science, they're expanding how we feel discovery. And in a world where black holes sound like deep cello notes and supernova look like abstract expressionist explosions, that might be the most important collaboration of all. Jules Verne didn't just write adventure stories, he blueprinted the future. When his 19th century readers thrilled to From the Earth to the Moon, they were absorbing more than fiction. They were glimpsing a technical manifesto. Verne's canon launched spacecraft, his calculations of escape velocity, even his Florida launch site. All were eerily prophetic, inspiring pioneers like Konstantin Tsiolkovsky and Robert Goddard to turn fantasy into equations. Decades later, Goddard would credit Verne's impossible lunar canon as the spark that ignited his lifelong obsession with rocketry. The line between art and invention has always been porous, but sci-fi doesn't just predict technology, it primes humanity to want it. Consider Star Trek's communicators, those flip-top devices that seemed laughably futuristic in 1966. Today, we call them smartphones. The show's touchscreen tablets, voice-controlled computers, and even medical tricorders didn't just anticipate real innovations, they normalized them, making the implausible feel inevitable. Engineers at Apple and Motorola have openly admitted cribbing from Trek's interfaces, proving that sci-fi's greatest power isn't foresight, but provocation. When Gene Roddenberry imagined a handheld diagnostic tool, he wasn't describing existing science. He was issuing a challenge. Why not now flip the script? For centuries, Mars was just a red dot until Percival Lowell's telescopic sketches of canals fired the public imagination. fueling a century of Martian sci-fi from Wells to Bradbury. When the Viking landers finally touched down in 1976, they found no canals, but they did reveal valleys carved by ancient water, vindicating the broader intuition that Mars was a world of secrets. Fast forward to 2015, when the discovery of flowing brine on Martian slopes made the Martian survival tale suddenly less far-fetched. Art and science aren't just trading ideas, they're engaged in a call and response across generations, each validating the other's boldest leaps. This feedback loop reaches its zenith with exoplanets. When Star Wars depicted Tatooine's twin suns in 1977, astronomers hadn't yet confirmed a single planet beyond our solar system. Today, we've found thousands, including real-world versions of Luke Skywalker's homeworld like Kepler 16b, orbiting two stars in a configuration straight out of George Lucas's sketchbook. Sci-fi authors, freed from the constraints of known physics, imagined frozen ocean worlds, diamond planets, and hyperstorms long before telescopes caught up. Now, as artists render newly discovered exoplanets like the lava-covered K2 141b or the iron rain-drenched WASP 76b, they're not just illustrating data. They're keeping the cycle alive, seeding the next generation's ambitions. Perhaps that's the most electrifying lesson. Science fiction isn't a crystal ball. It's a catalyst. Every time a researcher cites 2001 HAL as a cautionary tale for AI ethics, or a physicist name checks Interstellar's tesseract while explaining higher dimensions, they're acknowledging art's role as co-pilot to discovery. The warp drive may still be fantasy, but the dream it represents, the urge to vault beyond limits, is what fuels real breakthroughs. So the next time you spot a sci-fi gadget gathering dust in a museum, look closer. That failed prediction isn't a dead end. It's a stepping stone, one more voice in the eternal dialogue between what is and what could be. Dante didn't just write a poem, he built a universe. In the Divine Comedy, every line is a celestial coordinate, mapping the medieval cosmos with terrifying precision. Hell's frozen core mirrors the outermost sphere of heaven, both prisons of absolute isolation, one by fire, the other by ice. The concentric circles of Inferno aren't just moral allegory, they're a cosmological model, reflecting the geocentric spheres of Ptolemaic astronomy. When Dante ascends through the planetary orbits toward the Empyrean, he's not merely describing salvation. He's conducting a 13th century thought experiment. What if the soul's journey mirrored the star's motion? Centuries before Hubble, poetry had already collapsed the distance between human emotion and cosmic mechanics. Fast forward to Walt Whitman, who traded Dante's rigid heavens for a sprawling, democratic cosmos. His When I Heard the Learned Astronomer doesn't just romanticize the night sky, it rebels against cold calculation, choosing instead to wander off by myself and feel the stars. Whitman's verses pulse with cosmic intimacy, comparing the body's atoms to stardust long before scientists confirmed it. I contain multitudes, he wrote, unknowingly foreshadowing modern microbiology's revelation that our cells host bacterial ecosystems as vast as constellations. For Whitman, the universe wasn't an external marvel, it was a mirror. Today, poets like Tracy K. Smith, former U.S. poet laureate and daughter of a Hubble engineer, push this dialogue further. Her collection Life on Mars weaves astrophysics into elegy, imagining her late father somewhere in the heavens, laughing as telescopes reveal exoplanets. One poem, The Universe original motion picture soundtrack, recasts the Big Bang as a symphony's opening chord, while another, My God, It's Full of Stars, borrows 2001 cosmic awe to grapple with grief. Smith's genius lies in her refusal to separate science from soul. When she writes, dark matter in us / proving us / at once substantial / and illusory. She's not just riffing on physics jargon. She's exposing the shared fragility of quarks and human hearts. But why does this matter? Because poetry's metaphors often arrive before science's proofs. When Rainer Maria Rilke wrote of the night that terrifies with its vastness, he channeled the same existential dread that later birthed dark energy theory. Margaret Atwood's The Moment when, after many years / of hard work and a long voyage / you stand in the center of your room, could describe the James Webb Telescope's first calibration images, humanity collectively holding its breath. Even Emily Dickinson's "I Heard a Fly Buzz When I Died" resonates oddly with the sound of a black hole, that seismic B-flat 57 octaves below middle C. This back and forth reveals something profound. The best poetry, like the best science, thrives on unanswerable questions. When Dante's Pilgrim asks Beatrice why the moon's spots exist, she doesn't recite medieval astronomy. She tells him to bring her a cup of water to observe how light fractures differently in pure versus murky liquid. It's an experiment disguised as metaphor, proving that curiosity transcends disciplines. Whether through sonnets or spectral analysis, we're all chasing the same shimmering truth, that the universe isn't just above us, it's within us, waiting for the right words or equations to set it free. Virtual reality doesn't just show us the cosmos, it drops us into the heart of it, transforming abstract data into something visceral. Picture strapping on a headset and suddenly standing on the rust-colored dunes of Mars, the sky a pale pink haze as dust devils twist in the distance. This isn't science fiction. It's what VR artists like Eliza McNitt create in collaborations with NASA, using real rover topography data to craft landscapes so precise, geologists use them to plan missions. Every boulder, every crater slope is rendered from laser scans of the Martian surface. But the genius lies in what they add: the whisper of wind simulated from atmospheric pressure models, the way light scatters through thin air based on spectral readings, even the subtle vibration underfoot as a distant quake rumbles drawn from InSight lander seismographs. These details aren't just decorative, they're emotional bridges, turning cold metrics into lived experience. The magic happens when scientific rigor collides with artistic intuition. Take artist-director Andrea German's Celestial Bodies, where users plunge into the Orion Nebula's glowing clouds. The gas densities and stellar wind patterns are mapped from Hubble and Webb data, but the colors, those cascading violets and golds, are amplified, tuned to human perception. Why? Because nebulas in true, visible light often appear faint and reddish to our eyes, their full grandeur only revealed through long exposure photography. German's team consulted astrophysicists to ensure every artistic liberty still respected underlying physics, creating a hybrid of accuracy and awe. The result feels less like a simulation and more like a memory, as if you've always known what it's like to float inside a star nursery. This fusion is revolutionizing education too. Projects like Mission is a collaboration between Oculus and the European Space Agency. Let users navigate the International Space Station in zero gravity, their movements mirroring real astronaut training simulations. Floating through the cupola module, Earth rolling past the windows in real time via live satellite feeds, the experience bypasses textbooks entirely. Students who have struggled with orbital mechanics suddenly feel inertia and momentum as they reach for a handrail and overshoot, tumbling slowly. It's one thing to learn that space lacks up and down. It's another to lose them, your brain scrambling to reorient in a world without gravity. But the most profound impact might be therapeutic. VR studios like Marshmallow Laser feast craft experiences like we live in an ocean of air, where participants breathe with a giant sequoia, exhaling carbon dioxide that becomes branches, then stardust, then the breath of a whale, a poetic loop of interconnectedness backed by real biogeochemical cycles. For patients undergoing isolation treatments, from astronauts in training to immunocompromised children, these cosmic escapes offer more than distraction. They're lifelines to scale and wonder, reminders that loneliness is temporary against the backdrop of a universe that's vast but never truly empty. What's emerging isn't just a new medium, it's a new language for cosmic connection. When VR artists stitch together data from Chandra's X-rays, Spitzer's infrared, and Hubble's optics into a single navigable nebula, they're doing more than visualizing. They're translating, turning mathematics into metaphor, photons into pilgrimage. The equations haven't changed, but our relationship to them has. Suddenly, a black hole isn't just an entry in a physics paper. It's a place you can approach, its event horizon throbbing with distorted starlight, the pull of its gravity subtly warping your virtual hands as you reach toward the unknown. That's the alchemy of this work. It doesn't simplify the cosmos. It lets us inhabit its complexity, one impossible step at a time. Eduardo Cac's GFP bunny wasn't just a rabbit, it was a living, glowing question. When the artist genetically modified Alba to flourish under blue light in 1999, he thrust bioart into the spotlight, blurring the line between gallery and lab. But here's the twist. The same tools Cac used to create his luminous masterpiece, gene editing, synthetic biology, are now in the hands of astrobiologists searching for life on Enceladus or Mars. Both the artist and the scientist are asking the same radical question: what does it mean to be alive? And their answers are rewriting the rules of creativity in the space age. Bioart thrives on this tension between control and chaos. Take Oron Katz and Ionat Zer's victimless leather, a tiny jacket grown from living mouse cells in a bioreactor. It's a sculpture that pulses, metabolizes, and eventually dies, a commentary on consumption that also mirrors NASA experiments with lab-grown meat for Mars colonies. Or consider Christina Agapaki's Self-Made, where she collaborated with synthetic biologists to culture cheese from human bacteria, challenging our definitions of edible and alien. These works don't just sit on pedestals, they evolve, forcing us to confront life as a medium, one as malleable as clay or paint, yet infinitely more unpredictable. Astrobiology takes this uncertainty interstellar. When scientists design extremophile experiments, like exposing tardigrades to space vacuum or baking microbes in simulated Martian soil, they're not just testing survival. They're probing the boundaries of life itself, the same way Cac's Genesis encoded a biblical verse into DNA, then mutated it with UV light. Astrobiologists study how cosmic radiation might scramble the genetic blueprints of hypothetical extraterrestrial organisms. Both fields revel in transformation. A strand of DNA becomes art, a microbe becomes a Martian pioneer. The most electrifying collisions happen when these worlds merge. Artist Jonathan Keats' tardigrade spacecraft proposed sending microscopic water bears to Alpha Centauri in diamond-tipped capsules, turning them into both interstellar travelers and living sculptures. Meanwhile, NASA, a living color project, explores using bioluminescent bacteria as biosensors on other planets, organisms that change hue in response to environmental toxins, effectively painting planetary health in real time. These projects share a startling premise. Life isn't just something to find out there, it's something we might bring or even become. What unites bioartists and astrobiologists is their shared lexicon of wonder. They speak in proteins and pixels, Petri dishes, and deep-field telescopes. When Annika Yi cultivates microbial portraits from human sweat in You Can Call Me F, she's echoing the search for biosignatures in Europa's icy plumes, both hunting identity in the microscopic. When Neri Oxman 3D prints structures seeded with photosynthetic bacteria, she's prototyping the same kind of self-sustaining habitats we'll need on Mars. This isn't just interdisciplinary, it's trans-species, a dialogue stretching from Earth's labs to the far edges of the habitable zone. Bioart whispers to astrobiology, if life is a canvas, how far can we stretch it? And astrobiology answers, further than we've ever dreamed. Together, they're proving that the next renaissance won't be painted in oils. It'll be grown, coded, and launched into the cosmos, a living, breathing testament to creativity's infinite forms. When SpaceX launched a Tesla Roadster into orbit in 2018, it wasn't just a publicity stunt, it was a provocation. A red convertible drifting past Mars, broadcasting David Bowie's Life on Mars into the void, blurred the line between exploration and advertisement, between art and appropriation. Who gets to claim the cosmos as their canvas? The question grows louder as corporations stake claims on asteroids for mining and billionaires fund lunar landers emblazoned with logos. But this isn't just about celestial real estate. It's about something far more intangible, the right to imagine space, to depict it, even to profit from its likeness. Consider the case of the moon's far side. When China's Chang'e 4 probe touched down in 2019, it captured unprecedented images of the lunar surface, images the Chinese government promptly copyrighted. Suddenly, an ancient celestial body, visible to every human since the dawn of time, became subject to terrestrial intellectual property laws. Artists who incorporated these photos into their work found themselves in legal gray areas, echoing battles over indigenous cultural heritage here on Earth. The Maori fought for years to prevent corporations from trademarking their sacred Koru spiral. Now, the same questions arise when a nebulous shape appears in a video game or a galaxy's silhouette graces a corporate logo. The tension isn't new. When NASA Apollo missions returned with the first high-resolution moon photos, the agency released them as public domain, a gift to humanity. Yet today, private companies like SpaceX and Blue Origin routinely restrict access to their space imagery, treating it as proprietary data. Astrophotographers who spend years perfecting shots of the Andromeda Galaxy watch as their compositions get scrubbed from social media over dubious copyright claims, while stock photo sites sell space backdrops generated by algorithms trained on Hubble's open-source data. The irony stings. The universe belongs to everyone, but its representations increasingly belong to someone. Indigenous perspectives offer a crucial counterpoint. For the Navajo Nation, the moon isn't just a rock. It's a living entity central to creation stories. When NASA planned to scatter human ashes on the lunar surface via commercial landers, the Navajo protested, calling it desecration. Their argument mirrors concerns over sacred sites on Earth, from uranium mining near tribal lands to tourists trespassing on holy mountains. If a mountain can be sacred, why not a crater? If a river can hold spiritual significance, why not the plasma currents of the sun? Artists are pushing back with radical collaborations. The Open Space Project, led by digital creators and astronomers, crowdsources cosmic imagery under Creative Commons licenses, ensuring no single entity controls our view of the stars. Meanwhile, initiatives like the Decolonizing Mars Collective reimagine space exploration through indigenous futurism, blending traditional star knowledge with speculative art to challenge colonial narratives. Their work asks, what if the first Martian city isn't named after a tech billionaire, but after a Polynesian navigator who read the heavens long before telescopes existed. The stakes transcend legality. When we let corporations monopolize space's visual language, we risk shrinking the cosmos into something transactional, a backdrop for ads, a trophy for the wealthy. But when artists reclaim it, they remind us that the stars have always been humanity's first shared story, etched on cave walls and whispered in myths. The question isn't just who owns the moon, it's who gets to define what the moon means, and that's a debate too vast for any copyright office to contain. A neural network scans a dataset of 10,000 galaxy images, spiral arms, elliptical blurs, colliding giants, until it learns the mathematical essence of galaxiness. Then, with a click, it generates something never before seen. A cosmic whirlpool with violet dust lanes twisting around a sapphire core, a vision no human hand sketched. This is AI-generated space art, where algorithms like Google's Deep Dream and NVIDIA-style GN transform raw telescope data into surreal nebulae and impossible star clusters. The results dazzle, swirling supernova rendered in Van Gogh's brushstrokes, exoplanet landscapes that blend Hubble precision with Dali's dream logic. But beneath the spectacle lies a dilemma. When an AI trained on Cassini's Saturn photos produces a ringed planet with hexagonal storms at both poles, a configuration physics forbids, is it being creative or just confidently wrong? The debate splits the astronomy and art worlds. Purists argue tools like Mid-Journey and DALL-E are mere parrots, remixing human work without understanding. They point to AI's tendency to garble detailed stars that defy gravity, nebulae with impossible thermodynamics, as proof machines lack the intuition of artists who have spent nights under real skies. Yet pioneers like digital artist Anna Ridler collaborate with AI differently, training models on her own handmade galaxy paintings, then guiding outputs like a gardener pruning wild growth. Her Mosaic of the Sky series lets the AI suggest forms, which she then refines with astrophysical accuracy, blending algorithmic spontaneity with human curation. It's not about replacing artists, she insists, but expanding their palettes using AI as a cosmic brainstorming partner. Meanwhile, scientists harness these tools for discovery. At the SETI Institute, researchers feed AI-imagined biosignatures, hypothetical chemical combinations alien life might produce, and task it with painting atmospheric spectra as abstract art. The goal: to train astronomers to recognize truly novel patterns. Similarly, NASA Frontier Development Lab uses generative adversarial networks GAN to simulate asteroid surfaces, creating millions of synthetic terrains to prepare rovers for the unknown. Here, AI's mistakes boulders floating at odd angles, craters with unnatural shadows become strengths, stress-testing human assumptions about what's possible. The heart of the conflict isn't technical, it's emotional. When Hubble's Pillars of Creation image went viral, its power came not just from the science, but from knowing human minds built the telescope, human hands processed the data. Can an AI's nebula, however gorgeous, evoke the same awe if we know no one felt its creation? Yet perhaps that's missing the point. When Rifik Anadol projects AI-generated galaxies onto facades like the Sydney Opera House, audiences don't marvel at the code. They gasp at the light, the same way we don't ponder pigments when standing before Monet's water lilies. The art isn't in the tool, but in the transcendent moment it creates. This tension mirrors astronomy's oldest struggle, balancing cold calculation with naked wonder. Galileo's sketches of Jupiter's moons were both scientific records and acts of devotion. The AI-generated starfields gracing today's planetarium shows follow that dual legacy. The algorithms may never grasp the chill of a desert night or the weight of a telescope's eyepiece, but they're weaving new myths for the digital age, ones where the cosmos isn't just observed or painted, but endlessly reimagined. Whether that's art or heresy depends not on the machine, but on us. A child's crayon drawing of a rocket isn't just colorful scribbles, it's the first brushstroke in a lifelong conversation with the cosmos. Think back to your own childhood, the wobbly stars glued to shoebox planetariums, the tin-foil Saturn rings dangling from bedroom ceilings, the stick-figure aliens waving from construction paper Mars. These creations might seem whimsical, but they're stealthy gateways to scientific thinking. When a 7-year-old sketches a spaceship, they're not just imagining propulsion systems, they're subconsciously grappling with Newton's third law. Every action has an equal and opposite reaction. That lopsided lunar rover, it's a prototype engineering challenge, balancing wheels and weight distribution. Art becomes the unsung hero of early STEM education, disguising complex concepts as play. NASA understands this alchemy better than anyone. Their annual Art and the Cosmic Connection program invites kids to reinterpret spacecraft images of Jupiter's storms or Martian sunsets, blending observation with creativity. One winning piece from a 10-year-old depicted Europa's icy crust cracking like a frozen pond, with imagined bioluminescent fish glowing beneath, a vision that coincidentally mirrored astrobiologists' hypotheses about subsurface life. Other initiatives like the Name the Rover contests or the Moon Pod Essay Challenge don't just solicit ideas, they validate children's voices as co-creators of humanity's space narrative. When 9-year-old Clara Ma named Curiosity in 2008, her handwritten explanation, "Curiosity is the passion that drives us through everyday life," became a mantra for the entire mission. The magic lies in art's permission to fail gloriously. A child painting a purple and green nebula isn't constrained by the laws of spectroscopy. They're free to explore, invent, and ask, what if? That freedom often leads to startling insights. Take 11-year-old Julian's design for a Mars habitat, which included gardens watered by melted polar ice, a concept NASA later explored in their Mars Ice Home project. Or the elementary school class that proposed using mycelium mushroom roots to grow space station structures, an idea now being tested by scientists at Stanford. These aren't lucky guesses, they're proof that unfiltered creativity can bypass adult biases, arriving at solutions formal education might overlook, but the impact goes deeper than practical innovation. Psychologists studying NASA youth art archives noticed a pattern. Children who drew themselves as astronauts regardless of gender or background were significantly more likely to pursue STEM careers. The act of visualizing oneself in space, even through crude stick figures, builds what researchers call possibility identity. It's why initiatives like the Space to Ground project partner with Title I schools, giving underserved kids telescopes and art supplies to document their cosmic visions. When a black girl sees her self-portrait displayed beside the Hubble control room, or a rural student's alien ecosystem drawing gets pinned to an astrobiology lab's inspiration board, the message is clear: you belong here. The proof is in the professionals. Astronaut Nicole Stott began as a kid painting Florida's starry skies. She later orchestrated the first spacewalk to repair Hubble. Planetary scientist Carolyn Porco credits her career to a childhood obsession with sketching lunar phases. Even Einstein famously credited his theory of relativity to a teenage daydream about riding a beam of light, a thought experiment that began as mental art. Today's stick figure rockets might be tomorrow's warp drives, not because every doodle holds hidden genius, but because art nurtures the irreplaceable courage to wonder aloud. So the next time you see a child's glitter-covered solar system mobile spinning wildly off balance, Don't just smile and nod. Lean in. That chaotic whirl of glue and imagination might just be the first draft of our future among the stars. Climate change art holds up a mirror to Earth's future by borrowing Mars' desolate reflection. Take the work of artist Michael Benson, who processes raw NASA imagery into haunting diptychs. On one side, the cracked riverbeds of California's drought-stricken Central Valley. On the other, the ancient flood channels of Mars' Jezero crater. The resemblance is uncanny, but the message is urgent. This is what happens when water vanishes for good. Scientists studying Martian geology have long used its dry riverbeds and evaporated lakes as cautionary tales, but artists like Benson make that comparison visceral. When you see Earth's withering farmlands framed alongside Mars' fossilized deltas, the abstraction of climate change collapses into something immediate. That's the power of this crossover. It doesn't just inform, it implicates. The technique isn't limited to photography. Sculptor Luke Jerram's Gaia, a towering, internally lit replica of Earth based on a blue marble imagery, hangs in cathedrals and museums, forcing viewers to confront the planet's fragility from a God's-eye view. Pair it with his Museum of the Moon, and the dialogue sharpens. One sphere lush with swirling clouds and blue oceans, the other a pockmarked desert. The installations don't need placards to explain atmospheric loss or the greenhouse effect. The contrast speaks for itself, a silent scream about what happens when a world loses its protective embrace. This synergy between art and planetary science thrives on shared tools. Just as climate models project Earth's future by analyzing Martian ice core analogs, artists like Andrea Polly simulate airborne particulate data into swirling animations, making pollution visible as aesthetic horror. Her Particle Falls project transforms real-time smog readings into cascading projections on urban walls, a digital waterfall that turns crimson as toxin levels rise. The effect is part Baroque fresco, part environmental dashboard, proving that data doesn't have to be dry to be devastating. Perhaps the most provocative works come from the solastalgia movement, art that grieves ecological loss before it's fully gone. At the Venice Biennale, the Icelandic Love Corporation installed a melting glacier's groans recorded by geophones in a palazzo's ballroom, while Agnes Dean's future ruins planted wheat fields in Manhattan as both a promise and a eulogy. These pieces resonate doubly when viewed through an astrobiological lens. Dean's golden stalks swaying against skyscrapers evoke visions of Earth as a future Mars, a once fertile world remembered only in archives. The ultimate takeaway isn't despair, it's perspective. When the pale blue dot image reduced Earth to a speck in Voyager's grainy shot, Carl Sagan called it the only home we've ever known. Today's climate artists expand that insight, using Mars as a time machine to show where we're headed, and Earth as a living masterpiece we're still barely in time to save. Their work doesn't just bridge science and activism. It turns planetary science into the most urgent form of poetry, where every dataset is a stanza and every brushstroke a warning written in starlight. H.P. Lovecraft didn't invent cosmic horror, he channeled it straight from the universe's darkest corners. His infamous line, "The oldest and strongest emotion of mankind is fear, and the oldest and strongest kind of fear is fear of the unknown," could double as an astronomer's motto. When Lovecraft described Cthulhu lurking in the abyss or the color out of space poisoning a farm with extraterrestrial radiation, he was tapping into the same dread that grips us when we peer too long at Hubble's deep field. The vertigo of realizing how small, how fragile, how temporary we are against the cosmic scale. His monsters weren't just creatures, they were metaphors for the void itself, entities so ancient and vast they rendered human existence meaningless. And here's the chilling part, modern science keeps proving him right. Take rogue planets, worlds untethered from any star, drifting through interstellar space. Astronomers estimate there are billions of them, dark and silent, their surfaces frozen to near absolute zero. Lovecraft's Yithians, who hop between dying worlds, suddenly feel less like fantasy and more like prophecy. Or consider gamma-ray bursts, the universe's most violent explosions, capable of sterilizing entire galaxies in seconds. In The Call of Cthulhu, Lovecraft wrote of cyclopean cities lost to time, but modern telescopes reveal real ruins, supernova remnants, and neutron star collisions where physics bends into nightmares. The great old one's indifference to humanity mirrors black holes' relentless pull, impersonal, inevitable, and utterly uncaring. This terror thrives in modern horror games where real astronomy heightens the unease. Dead spaces mark a monolith, broadcasting signals that twist minds. Echo the mysterious fast radio bursts (FRB) detected by radio telescopes, powerful, repeating signals from deep space with no confirmed origin. The game's derelict spaceship, the Ishimura, orbits a dying star being harvested for resources, a scenario not far from proposed stellar mining concepts for red giants. Even Amnesia, a machine for pigs, weaponizes the vastness of space, with its antagonist ranting about the great black swine in the sky, a nod to humanity's insignificance against the cosmos. The most unsettling twist: these games don't need aliens to frighten us. The vacuum itself is antagonist enough, a silent, airless killer lurking just beyond the hull. But why does space unsettle us so deeply? Psychologists point to the overview effect, the cognitive shift astronauts experience when seeing Earth from orbit, a sudden, crushing awareness of our planet's isolation. Artists like Z.D. Zislaw Beksinski and H.R. Giger externalize this dread, painting landscapes where biology and machinery fuse into something neither alive nor dead, much like the extremophiles clinging to hydrothermal vents on Europa. Even Arrival's heptapod language, with its circular symbols representing time as non-linear, mirrors quantum physics mind-bending truths about causality. The unknown isn't just scary, it's addictive. We keep staring into the void precisely because it stares back, demanding we reconcile with our own fragility. Perhaps that's cosmic horror's greatest lesson. When Lovecraft wrote of the black seas of infinity, he wasn't just spinning tales. He was naming the unease that lingers after every major astronomical discovery, the humbling reminder that for all our curiosity, the universe remains indifferent. Our art and our science are twin attempts to carve meaning from the dark, whether through equations or eldritch poetry. So the next time you feel a shiver watching a pulsar's flicker or playing a horror game set on a frozen exomoon, remember that fear isn't weakness. It's the oldest reminder that we're alive and the cosmos is very, very old. Medieval monks hunched over parchment didn't just illustrate the heavens, they mapped the divine. In the Book of Kells, celestial initials twine with constellations, while Hildegard of Bingen's Scivia's visions painted the cosmos as a nested egg, each layer a sphere of angels and fire. These weren't mere decorations, they were acts of devotion, collapsing the distance between Earth and God's throne into something tactile. Fast forward to the 21st century, where Tibetan monks sculpt intricate mandalas from colored sand, only to sweep them away, a ritual mirroring the birth and dissolution of stars. Sacred art has always been cosmic art, long before telescopes revealed the true scale of the void. The Renaissance shifted the lens but kept the awe. Michelangelo's Sistine Chapel ceiling isn't just a Bible scene. It's a cosmological diagram. God's outstretched finger ignites Adam with the same spark that lit the Big Bang, the swirling drapery behind him echoing the proto-galactic clouds Hubble would photograph centuries later. Even the chapel's architecture reinforces this. Standing beneath it, you don't just look up at the creation, you're drawn into it, as if the vault opens straight to the primordial moment. This wasn't accidental. The Church understood that to make the infinite relatable, you must render it in human terms, whether through frescoes of a bearded creator or Dante's poetic ascent through the celestial spheres. Modern sacred artists face a starker challenge: how to depict transcendence when science has stretched the cosmos beyond medieval imagination. James Turrell's skyspaces offer one answer. These minimalist chapels frame patches of open sky, transforming sunlight and passing clouds into living stained glass. As dawn paints the interior shifting hues, the effect is less about depicting heaven and more about experiencing it, a meditation on light's primal role in both physics and spirituality. Meanwhile, Janet Mackenzie's Our Lady of the Cosmos reimagines the Virgin Mary as a universal mother, her cloak patterned with galaxies, her child cradled against a backdrop of swirling nebulae. The message is clear: the sacred doesn't shrink before the vastness of space, it expands to meet it. Perhaps no work bridges this divide more hauntingly than the Dark Madonna of Czestochowa, whose centuries-old icon was recently scanned using astrophysical spectrometry. Scientists discovered her pigments contained traces of meteoritic iron, literally stardust. In that revelation, art, faith, and science collapse into a single truth: the materials of devotion and the stuff of supernova are one and the same. From gold leaf halos to Hubble's gold-filtered nebula images, we've always gilded the infinite to bring it closer. Today's cosmic psalm might be the echoes of light installation at the Vatican Observatory, where fiber optics translate real-time gamma-ray bursts into flickering constellations above a chapel altar. Each pulse is a prayer in reverse, a celestial event witnessed first by satellites, then sanctified by human hands. This dialogue between lab and sanctuary reminds us that wonder needs no dogma. Whether through a monk's illuminated comet or a quantum physicist's awe at entangled particles, the instinct is identical: to kneel, metaphorically or otherwise, before the mystery that binds atom to altar, void to verse. Our journey through these 15 cosmic bridges leaves us with a revelation as vast as the universe itself. Art and astrophysics were never truly separate disciplines. They're simply different dialects of the same eternal conversation. Like binary stars orbiting a shared center of gravity, creativity and calculation draw their power from one another. Van Gogh's turbulent skies and the equations describing galactic spin, the golden ratios echo from sunflowers to spiral galaxies. Even the way a black hole's silhouette mirrors Malevich's black square, all whisper the same profound truth. The universe doesn't compartmentalize, it connects. Consider the sheer improbability of it all. A species that evolved to track predators on the savannah now tunes radio telescopes to capture the birth cries of stars. The same hands that once painted bison on cave walls now manipulate Hubble's data into rainbow-hued nebulae. We've spent millennia projecting our myths onto the constellations, only to discover those very stars are forging the elements of life itself in their cores. The urge to create and the hunger to understand aren't just parallel drives, they're entangled, like particles sharing quantum states across light years. This convergence isn't accidental, it's survival. When the first humans traced the Pleiades in ochre on stone, they weren't just decorating. They were encoding survival, predicting seasons, navigating migrations. Today, when a physicist scribbles equations for dark matter or an artist renders an exoplanet's imagined skies, we're still solving the same primal puzzle. Where do we fit in this grand design? The tools have changed charcoal to supercomputers, star lore to spectroscopy, but the quest remains: to map the unmappable, to name the unnameable. So what do we do with this knowledge? We keep bridging. When you next stand beneath a meteor shower, let yourself feel the duality. Count the streaks like a scientist tallying debris, but also like a poet measuring stanzas. When you encounter a Pollock drip painting, admire its chaos as both an artistic revolution and a turbulent simulation. Share these overlaps, sketch the moon's phases in your journal, compose a melody from planetary orbital frequencies, or simply lie in the grass and let your eyes blur the stars into constellations old and new. The comment section below isn't just a forum, it's a continuation of this cosmic dialogue. Which of these 15 insights sparked your sense of wonder? Was it the fractal harmony of neurons and galaxies, or the way gravitational lensing bends light like a cubist masterpiece? Your perspective adds another dimension to this exploration. And if you've enjoyed tracing these threads between the laboratory and the studio, hit subscribe. We've barely scratched the surface of the universe's grand collaboration. The canvas is infinite, and every discovery, whether painted or calculated, reveals another brushstroke in the masterpiece we call reality. As we sign off, here's a final thought to carry under the night sky. Every time an artist mixes pigment or a physicist calibrates a telescope, they're asking the same fundamental question. Not how the universe works, but why it moves us. The answers may vary, but the ore remains a shared language written in stardust and stories, equations and emotions. So keep gazing upward and inward, because the most breathtaking discovery isn't out there or in here. It's in the space between, where wonder lives.